Hey, this is Unit 8, Video 4, calculations involving equilibrium constant. Okay, so once again, we've learned how to write the equilibrium expression, which is going to be our products, the ratio of our products over our reactants. So what we have on the board is we have a couple of problems here. We're going to walk through how to determine the equilibrium constant. So here we've got carbon monoxide reacting with water to produce carbon dioxide gas and hydrogen gas. Okay, now notice these are all gases, so they're all going to be used in our equilibrium expression. So let's go ahead and, before we even look at this problem, let's go ahead and write the equilibrium expression. So we know that our equilibrium expression is going to be the concentration of our products, okay, raised to the power. So this is CO2, we've only got one, so to the first power, times the concentration of hydrogen gas to the first power, divided by carbon monoxide's concentration raised to the first power, times the concentration of water to the first power. Okay? Now let's look at the problem. It says if the equilibrium concentrations for carbon monoxide, water, carbon dioxide, and hydrogen gas are 0.1 molar, 0.1 molar, 5.2 molar, and 0.6 molar, determine K. So we've already got our equilibrium constant, or equilibrium expression written, so now we can just plug these numbers into the equilibrium expression. So here, carbon dioxide is going to be 5.2 molar. We're going to have 5.2 times the concentration of our hydrogen gas, which hydrogen gas is going to be 0.6 molar. Okay, divided by the concentration of our reactants. So our reactants were carbon dioxide and water, so we're going to have 0.1 molar. Times 0.1 molar. Okay, so if you were to punch all that into your calculator, you would get that the equilibrium expression would be equal to right about 312. So what this means is that if we change the concentrations of reactants and products, and we go through and we calculate the equilibrium expression, if it is 312, no matter what the concentrations are, we are at equilibrium. So the rate of the forward is still equal to the rate of the reverse. If it does not equal our equilibrium constant, we're no longer in equilibrium. Okay, so let's look at another problem over here, which we are decomposing ammonium nitrite, and so it's decomposing into nitride and water. So, I'm sorry, nitrogen and water, not nitride. So here it says, if 10 grams of ammonium nitrite decomposes at equilibrium, 1.5 molar of nitrogen gas is measured. What is the concentration of steam? So we want to know the concentration of steam. This is, okay. So let's go through and write our equilibrium expression before we go through and calculate anything in the problem. So here, this is a solid, so it's not going to be used in our reaction. So if you look at, equilibrium expression. So here, if you look, it says 10 grams of ammonium nitrite. Well, it's not going to be used, so it doesn't matter because we're not going to use it in our equilibrium expression. So if we go to write our equilibrium expression, okay, it's going to be the concentration of our products. So we're going to have N2 times water, which is going to be raised to the second power. Okay, and we don't have any reactants that are going to be involved in the equilibrium expression, so we're just going to write it as 1. Okay, so now let's go through and plug in what we've been given in the problem. So it decomposes at equilibrium. We've got a 1.5 molar N2. So we know what N2 is. N2 is 1.5 molar. We want to know the concentration of water, so we do not know water. Okay, but what we do know is I gave you the equilibrium expression. Equilibrium expression is 1125. Okay, so we can get rid of this square by taking the square root. So if we were to get all of this by itself, we need to get H2 water by itself. So we're going to end up, I'm sorry, probably should have rearranged this before we go doing that. So we're going to end up with water, the concentration of water, equaling the square root of 1125 divided by 1.50. If you punch that into your calculator, you'll get that the concentration of water is equal to 27.5 molar. Is going to be our concentration of water.